So the final level of complication for today is what happens if you rotate around the axis that isn't the y-axis. Let's say we have, let's make it as complicated as we can. Let's say we have the curve y equals f of x, and we have the curve y equals g of x. Between A and B, we have this distance right here, this area right here, and we want to rotate it not around the x-axis, but around a different axis. What happens if we want to rotate it around, well, what if we rotate it around here? Y equals C. Well, let's go back to our slices. First, we're going to take this area and rotate that, and then later we're going to take this area and rotate that and subtract them. Well, let's worry about the red one first. Well, if we slice it, what have we got? If we're at some point x star, let's do the cheaty thing where we look at it as infinitely thin. Because the limit as n goes to infinity, it is making things infinitely thin. This is going to slice into a circle. And what we care about is what is the radius of this circle. The radius is, well, it's f of x minus c. F of x goes from here to here, and that's f of x. Goes from there to there, and c goes from there to there. So it's f of x minus c. And we add those all up from top to bottom, and so the red area, the red volume, when we rotate it, is going to be the integral from a to b of pi, not f of x, but f of x minus c squared dx. And then, oh goodness, what is it? And then the green area, this part in here, which we want to take out. See, we want to take that and rotate that around. Take that out. What is that? Well, it's the same thing. It's g of x minus c is your radius. So why don't we just go straight to the full volume. Let me type this. Insert text box. The full volume of the region of the solid of rotation formed by rotating the area between y equals f of x and y equals g of x from x equals a to x equals b around the axis y equals c is, would have taken me so much longer to write that, is the integral from a to b of pi f of x minus c squared minus pi g of x minus c squared dx. And we can pull the pi out. But we can't really do too much else. This is pi times the integral from a to b f of x minus c squared minus g of x minus c squared dx. Now, if you're not sure which one's on top, ping, absolute values, and you're set. If they intersect in a couple places, if your two curves y equals f of x and let's say y equals g of x intersect somewhere between your a and your b, then you're going to have problems. What you have to do is you have to find that point, use the C, D. You have to find that point. You have to integrate this one first and then this one second and add them together. In fact, if you rotate around an axis C that's up above x equals c, y equals c, now, it doesn't matter. because f of x minus c is now going to be a negative number, if this is f of x from there to there, and this is c all the way up, then this is going to be this is going to be c minus f of x. But squaring it makes it not make any difference. So nice. So in this particular case, you would have to say the volume was pi, the integral from a to d of f of x minus c squared plus minus g of x minus c squared dx, and then we add to that pi from d to b, and now g of x is the outer one, so it's g of x minus c squared minus f of x minus c squared dx. And if you were getting confused or you weren't quite sure which was on top, absolute values, but you have to do the absolute values of them separately. You have to take care of the fact that it intersects. I don't feel like doing too much integration today. I feel like these videos are getting a little bit long as it is, but you know, let's say you had an example and you had I don't know, y equals sine of x, and you had y equals cosine of x, and let's say they meet at pi over 4 where they're both root 2 over 2, and oh, what the heck, so here's pi over 2 and here's pi. Well, yeah, let's rotate this area from 0 up to pi, and let's rotate it around the line. Let's see, the lowest these ever get, these go between 1 and negative 1. Well, let's rotate it around the point, I don't know, negative 1.5. What is the volume? The volume is the integral from 0 to pi over 4, because they intersect, we have to deal with them separately, of top function in that particular case is cosine of x minus negative 1.5 squared with the pi in front, minus pi sine of x minus 1.5 squared dx, and then we add to that the integral from pi over 4 to pi, and now sine is on the outside, so it's sine of x minus negative 1.5 squared minus with the pi. Think pi r squared, the area of a circle. We're adding up a whole lot of circles. Minus pi cosine of x minus negative 1.5 squared dx, and I think I'm running off the page. Anyway, I'm not going to do this. First of all, if you multiply this out loud, you're going to start getting things like cosine squared of x dx. We don't have the tools yet to deal with that. Substitution doesn't work. We don't, off the top of our head, know whose derivative is cosine squared. You might think cosine cubed, but no, you got chain rule in there. The derivative of cosine cubed is 3 cosine of x squared, yes, times the derivative of what's inside minus sine of x. So this is just an example. And it's a pain, but it works. And if you are wondering about what happens if you wanted to take some sort of area from A to B under the curve y equals f of x and rotate it around a vertical axis, that's what we're going to talk about next time.